Good evening, class 10. Today we'll continue with the previous chapter, that is atomic nucleus. Okay, last class we spoke about radioactivity. We spoke about the type of emissions that is emitted by a radioactive substance. We spoke about the properties of alpha, beta, gamma radiations. Right? So today we just radioactivity is basically what we'll not do the definition. Radioactivity is a nuclear phenomenon. Nuclear phenomenon. So what is the meaning of nuclear phenomenon? Nuclear phenomenon means it involves change in the constituents. It involves change in the constituents of a nucleus. What are the constituents of a nucleus? Protons and neutrons. So this you have to remember. Right? It is a nuclear phenomenon, which means change in the nucleus. Okay. Now we'll come to the important part. Changes in the nucleus. Changes in the nucleus on alpha, beta and gamma emission. What will happen to the nucleus of an atom when alpha particles are emitted, when beta particles are emitted, and when gamma particles are emitted? So first we'll speak about alpha emission. When an alpha particle is emitted by an atom means basically by the nucleus of an atom. Emitted by an atom, its mass number gets reduced by 4 and atomic number gets reduced by 2. This is the basic thing. When alpha particle is emitted, mass number reduced by 4, atomic number reduced by 2. We'll show this with an equation. Let's write the general equation. Suppose X is the initial atom with mass number A, atomic number Z will undergo alpha emission. It will give a new element Y. Mass number reduced by 4, so A minus 4, and atomic number reduced by 2, right? Plus 4 He2. This is alpha particle. Okay. Now this one, the initial element or the initial nucleus, we are going to call it as the parent nucleus or the parent atom. And this one, we'll be calling it as a daughter nucleus, the new one that is formed, daughter nucleus or atom. This is the general form. Okay, this is the general form. If I give an example, let's do the example. Uranium 238 mass number, 92 atomic number will give alpha particle and will form a new element with mass number getting reduced by 4. So 238 minus 4 will be 234. 92 minus 2 will be your 90. This is the new element form or the daughter element form. And we are going to get alpha particle. Okay. So here we have to remember left hand side atomic number, left hand side mass number will be equal to the right hand side atomic number and right hand side mass number. See here 238 we have the left hand side mass number, right hand side also we have 238, 234 plus 4. Then left hand side atomic number is 92, right hand side we have 90 here plus 2, so 92. So atomic number, mass number gets balanced over here. Okay, this we have to remember in all the emissions, whether be alpha, whether be beta, whether be gamma, we have to balance the mass number and the atomic number on both the sides. Now we come to gamma emission. Okay. Sorry, we come to beta emission, not gamma. I forgot. Beta emission. When beta particle is emitted by an atom, its mass number remains same, but atomic number increases by 1. Here there is no change in the mass number. Mass number remains same, atomic number increases by 1. This is the key point over here. Let's see the general equation. Here also we take an element X. A is the mass number, Z is the atomic number. It will give you beta particle. What is a beta particle? What is the symbol of a beta particle? It is basically an electron. We get a new element Y, so mass number will remain as A. Atomic number gets increased by 1, so Z plus 1. This is the general form. Now we'll give an example. Here X is the parent element or atom and Y is the daughter atom. Okay, let's give an example. Carbon 14 mass number, 6 atomic number, will give us an element, new element. Nitrogen 14 mass number will remain the same. Atomic number will be increasing by 1 unit, that is 6 plus 1, so 7. And we are going to get beta particle or electron. Okay. Now here also see left hand side mass number, atomic number, and right hand side mass number and atomic number, they are balanced. Here the mass number is 14, right hand side is 14 because it is 0. So 14. Left hand side the atomic number is 6. Right hand side see we have 7 and we have here minus 1. So it makes 6. Right, and here these two elements, they are different elements. They have different atomic number but their mass number is same. So I think you have already done this in your previous class. This type of elements, they are called as isobars. So in case of beta emission, we are getting isobars. Okay, this is important. Now let's go to gamma emission. Gamma emission when gamma particle is emitted by an atom, there is no change in its mass number. There is no change in its mass number and atomic number. So it remains as usual. Okay. Gamma particles are emitted by excited atom. Excited atom means what? High energy state. Okay, so they are emitted by excited atom or excited element. Okay, excited means whose energy is higher. So they come back to the lower energy state by emitting the gamma radiations. So in gamma particles, we don't have any change in its mass number, atomic number. No change in mass number and atomic number. Okay, and it is emitted by excited atom. Okay, so let's see this with the general equation. Element X, A, mass number, Z, atomic number, gives you Y, the daughter element or the new element. Okay, 1 minute. Sorry. Element X star will give you element X, A, Z plus gamma. Okay. Now this star means what? The star is your element in the excited state or the excited atom. Okay. The star indicates it is excited, means high energy. It is present in the high energy state. It will come back to its low energy by emission of a gamma particle. Okay. Here there is no change in the mass number and atomic number. A, here also A, Z, here also Z. Okay, this is low energy atom. Okay, this you have to remember. Okay, now few points under this. I'm writing those points by star. Alpha particles are emitted generally by heavier atoms. Beta particles are emitted by lighter atoms. Third one, gamma particles are emitted by excited atoms. Last, alpha and beta emission are accompanied by gamma emission. So the few points that has to be kept in mind. Okay, this much. Next, we have unit of radioactivity. Now, what is the unit of radioactivity? It is becquerel. Becquerel is a scientist who discovered radioactivity. He was the first one to observe. Becquerel is the SI unit of radioactivity. Okay. Other units we have Curie. This also you need to know. So these are the two units of radioactivity. Okay. Next, uses of radioactivity. First, 14 carbon 6, it is used to determine the age of fossils. Fossils means they are organic materials. Uranium 238 determine the age of old rocks. Cobalt 60, it is used for cancer treatment. Then iodine 131, goiter treatment. So the four isotopes, the four elements which are utilized in your in all these purposes. Now the last one, in photosynthesis. In photosynthesis, 14 carbon and 18 oxygen labeling was done to prove entire CO2, because we know in photosynthesis CO2 and H2O are the reactants. Entire CO2 gets converted to glucose, and oxygen liberated comes from H2O. This is very important, because without this labeling, this proof would have been difficult. So today this much. We'll continue the next part in the next class. So thank you.